So you hear all about these incredibly powerful AI models, right? But have you ever stopped to think, how do they actually do anything in the real world? Well, we're going to dive right into that. Today, we're talking about LangChain and how it takes a super smart AI from being just a brain in a jar to a fully functional, intelligent robot.
And really, this is the core of the problem. You've got these amazing models that can think, they can write, they can reason, but they're completely isolated. They're basically trapped inside a computer. So the big question is, how do we get them out of that jar so they can actually use our tools and work with our data? Okay, so let's make sure we're on the same page. A large language model, or LLM, that's the super smart brain we're talking about. It can write a song, it can ace a history test, it can even write code. But here's the catch. On its own, it has no connection to anything. It can't look at a website, it can't open a file on your computer, it can't book you a flight. It's just pure thought, waiting for a body.
And that's exactly where LangChain comes in. The best way to think about it is like a robot body kit. It's got all the wires, the arms, the sensors, everything you need to connect that powerful brain to the real world. LangChain is the framework that lets the AI finally interact with files, websites, databases, you name it.
So the goal here, the really big idea, is to move from just talking to actually doing. We want an AI that doesn't just say it'll do something, but one that can go out and do it. And that is the fundamental difference between a plain old LLM and what we call an AI agent.
Let's break this down. An LLM? That's a talking brain. You ask it something, it gives you an answer. Simple. But an agent? That's a talking brain with a plan. It doesn't just answer you. It thinks through the steps it needs to take and then goes and takes them. It turns words into action. Let's make this real. Imagine you tell an AI, hey, book me a haircut for Tuesday. A basic LLM might just say, okay, I will book you a haircut. But has it actually done anything? No. An agent, on the other hand, can actually execute a plan. It'll check your calendar, find the salon's booking system, call that system to make the appointment, and then come back and confirm with you. See the difference? Talking versus doing.
Okay, so this sounds great, but how do you actually build one? Well, LangChain gives us this amazing set of building blocks, kind of like a Lego kit for AI. You can snap these different pieces together to create some really sophisticated agents. So let's take a look at the core components in the box. First up, and this is the most important piece, is the model itself. This is the brain of our whole operation, right? It's the LLM that's doing all the thinking and all the talking. Everything else we build is going to be connected to this central brain. And what's cool about LangChain is that it's model agnostic. You're not locked into one brain. You can easily swap in models from OpenAI, from Google, from Anthropic, whoever. This gives you a ton of flexibility. You can use a smaller, faster model for quick and easy tasks, or you can bring out the big guns, a really powerful model for stuff that needs complex reasoning. All right, next up in our Lego kit, we have prompt templates. Honestly, the best way to think about these is like a Mad Libs sheet you give to the AI. It's a way to give it really clear, structured, fill-in-the-blank instructions. This makes the AI's responses way more consistent and reliable. And this is so important in the real world. Imagine a customer support bot. You can use a template to give it a personality, and more importantly, to set ground rules. You can say, look, you can only use this specific policy document to answer questions. And this is huge. If you don't know the answer, just say you don't know. That one rule prevents it from making stuff up. Now we're getting to chains. If prompts are how we talk to the brain, chains are how we make it do multiple things in a row. It's just like an assembly line. You can connect a series of steps where the output of step 1 becomes the input for step 2, and so on. It's how you build real workflows. A resume helper is a perfect example. Step 1, it takes in your messy resume text. Step 2, it sends that text to the model to rewrite it and make it sound more professional. Step 3, it takes that new text and formats it into clean bullet points. And step 4, you get the final, polished resume. Simple steps, chained together, create something really useful. This component, this is where our robot actually gets its hands. Tools are what allow the agent to reach out and do things in the real world. A tool is basically any function the AI can call to get new information or perform an action. This is the bridge from just thinking to actually doing. And you can fill this toolbox with all kinds of cool stuff. It could be something simple, like a calculator for math problems, or it could be way more advanced, like giving it the ability to look up a customer in your database, or call a shipping API to track a package, search through your company's internal documents, or even send an email on your behalf. Okay, next, our robot needs a memory. This one is so important. Without memory, every single time you talk to it, it's starting from scratch. It's like talking to someone with no short-term memory. So LangChain's memory components act like sticky notes, letting the bot remember what you've talked about before. And here's why that's absolutely critical. Let's say you tell the bot, hey, just so you know, my kid has a severe peanut allergy. That information needs to stick. So later when you ask, can you give me some lunch ideas? The agent remembers the allergy and makes sure none of its suggestions contain peanuts. That makes the whole experience smarter and, frankly, safer. Now for one of my favorite components, Retrieval. This is how you give your AI access to your own private knowledge base. The process starts with something called a vector store. The easiest way to picture this is a magic library. Instead of organizing books by author, it organizes them by the ideas inside them. So all the documents about similar topics are physically sitting right next to each other on the shelf, which makes finding them super fast. So if the vector store is a magic library shelf, the retriever is the genius librarian. When you ask a question, the retriever knows exactly which section of the library to go to and can pull the single most relevant page or paragraph to answer your question. It's incredibly good at finding the right information. This whole system is called Retrieval Augmented Generation, or RAG. It's a really elegant three-step process. First, the user asks a question, like, do you have cancellation fees? Then, the retriever, our librarian, goes into your private documents and finds the exact paragraph about the cancellation policy. Finally, it hands only that paragraph to the model and says, use this to answer the question. This ensures the answer is 100% accurate and based on your data. So when you put all of these Lego bricks together, the model, the prompts, the tools, the memory, the retrieval, what do you actually end up with? Well, it's way more than just a chatbot. It's a totally new kind of software. It's a move toward building things that are much, much smarter. I love this analogy. For decades, traditional software has been built like a train on a track. It's predictable, it's rigid, and it can only go where you've already laid the rails. But agentic software, the kind you build with LangChain, is like a smart delivery robot. You don't give it a path, you give it a goal, and it figures out the best way to get there, navigating around any obstacles it finds. It's flexible, it's adaptive. Just think about a question like this. A simple, rule-based chatbot would just break. It wouldn't know what to do. But an agent can actually reason its way through the problem. It can use its tools to search documents, it can identify the discount policy as the right piece of information, and it can put together a perfect answer that gives the user exactly what they need. It can think on its feet. And that's really the question we should all be thinking about now. This is a huge shift. For so long, building software has been about laying down those rigid train tracks. But now, for the first time, we have the tools to build things that are more like smart, autonomous robots that can think for themselves. So the only question left is, what are we going to build? You know, this quote just nails it. It perfectly captures that leap from a fun, chatty AI to something that's a genuinely useful helper. The keywords here? Follow steps, remember, and look things up. That is the difference between a toy and a tool, and that's exactly what we're going to build. Okay, so every great project starts with the basics, right? In this first part, we're just gathering our core components. Think of it as getting all the parts and the instruction manual ready before we start assembling our AI. And here it is, our 5-step game plan. This is literally the path from a completely blank screen to a fully featured AI application. We'll start with the simple stuff, the installation. Then, we'll teach the AI what to do with prompts, build the assembly line that connects everything, and then, the really cool part, we'll give our AI a memory and access to our own private knowledge. So, let's start with that first block, installation. Let's make this super simple. Before you can build that awesome Lego starship, what do you need? You need the box of Legos, right? This first step is just that, getting all the foundational pieces out and ready to go. So in our world, that Lego box is just the LangChain software package. Installation is nothing more than setting up that software on your computer. It's the digital equivalent of opening the box, dumping all the pieces on the floor, and getting ready to build. First things first, go ahead, pop open your terminal. Because this one line of code right here, this is your entry ticket. This is the command that kicks off your whole journey into LangChain's new, smarter architecture. Now, what's so cool about what just happened? Well, that one command didn't just install some single giant library. Nope. It very cleverly pulled in 3 separate foundational packages. And understanding this is the absolute key to the new LangChain. Okay, so let's break down what we just installed. We're going to start with the first and, the most fundamental piece of the whole system, the core engine. This is LangChain Core. The best way to think about it is like the chassis of a car. It's the foundation. It holds all the basic building blocks and, most importantly, the LangChain expression language, or LCEL. This is the special sauce, the powerful syntax that you're going to use to chain everything together. All right, let's move on to the next piece and see how this all connects. We've got the core, right? But now we need to actually talk to a model. And that is exactly where LangChain OpenAI comes in. Instead of bundling every model connector under the sun, this new approach is super lean. This package is just a dedicated, lightweight way to talk to OpenAI models like GPT-4. It's simple, it's efficient, and it gives you exactly what you need with no extra bloat. Okay, so we've got the core and we've got a direct line to OpenAI. But what about, well, everything else? And that brings us to the final and honestly, the biggest piece of the puzzle. This is where the power of the whole ecosystem really shines. LangChain community. Think of this as your massive open source toolbox. I mean, it is just jam-packed with third-party integrations, all sorts of vector stores, data loaders, special tools, all of it contributed and kept up to date by the community. So just to recap real quick, this table lays it all out perfectly. You've got LangChain Core, that's the foundation, the rules of the road. Then LangChain OpenAI is your dedicated high-speed connection. And finally, LangChain Community is that giant treasure chest for everything else. It's just a really clean, logical separation.
So you did it. You made your first API call, you sent a question to a model, and bam! You got a surprisingly great answer back. It feels like pure magic, doesn't it? But here's the thing about that magic moment. It's fleeting. The real question, the one that separates the hobbyists from the pros, is what's next? How do you take that one-off success and actually build a reliable product on top of it? And that really brings us to our first big idea, going beyond the first API call. This is all about making that critical shift in mindset, moving from playing with a toy to building with a tool. And believe me, that requires a completely different way of thinking, a real engineering mindset. Because here's the thing, and this is so crucial. Pretty much anyone can get an LLM to work once. That's the easy part. The real challenge, the engineering challenge, is getting it to work consistently, predictably, every single time. That's the gap we're here to talk about today. Okay, so where do we start? Well, we start by taming the model. See, to build something reliable, we absolutely have to bring some structure to what is, let's be honest, the most powerful but also the most unpredictable part of our entire app, the model itself. I want you to picture this. Think of a raw LLM, a GPT-4o, a Llama 3, as this massive, powerful V8 engine block sitting on a pallet. It has incredible potential, right? But you can't just drop it into a car and expect it to go. No way. It needs fuel lines, an exhaust system, standardized mounts. It needs a proper interface to actually connect to the rest of the car. And that interface, in our world, has a name. It's called a model wrapper. It's basically a layer of code that, well, it wraps around the language model, sitting right between your app and the AI. Its whole job is to give you a standardized, predictable way to talk to that AI, no matter which model you happen to be using under the hood. So why bother with these wrappers? What do they actually do for you? Well, it boils down to 3 huge advantages. First, they standardize your inputs and outputs so you always know what to expect. Second, and this is a big one, they let you swap different models in and out super easily. We'll come back to why that's a total superpower in a sec. And third, they just help you write cleaner, more organized AI logic. And just look at how simple the code becomes. Instead of dealing with all this messy, raw API request stuff, you just create a chat OpenAI object, tell it which model you want, like GPT-4o mini, and then you just .invoke it. That's it. The wrapper takes care of all the complicated stuff in the background for you. So let's bring it back to that car analogy. The model wrapper, that's your standardized engine mount.
It's what lets you lift out that GPT-4o engine and just drop in a Llama 3 or a Claude 3 right in its place, without having to rebuild the entire car from scratch. It just fits.
Okay, but why is swapping models such a big deal? Well, here's a perfect real-world scenario. Imagine you use a really fast, cheap model for, say, 90% of your users' simple questions. But then, when a really complex or sensitive task comes along, your code can instantly and automatically swap in a much more powerful and, yeah, more expensive model just for that one job. That isn't just cool, that's smart, cost-effective engineering.
Okay, great. So now your model is flexible, it's standardized, you've got it tamed. But what about the instructions you're actually giving it? Because let's face it, if your instructions are messy and inconsistent, you can bet your output is going to be messy and inconsistent too.
And this leads to our next big section, and it's a huge mindset shift. Prompts are code. You have to stop thinking of your prompts, that text you send to the LLM, as just casual questions. In a real production-grade system, your prompts are a critical piece of your application's logic. They are code.
This right here really gets to the core of it. On one hand, you've got prompting as vibes. You just kind of type something in and hope for the best. It's inconsistent, it's impossible to test, and it's a total one-off. On the other hand, you have prompting as code. This is the professional approach. Your prompts are versioned, they are testable, and they are built to be reusable.
So how do we do that? Well, the main tool we use is something called a prompt template. Seriously, just think of it like a recipe, or maybe like one of those Mad Libs books. It's a predefined structure for your prompt, but it has these little empty slots, these placeholders that you can fill in with dynamic info later.
And here's what that looks like in the code. You see how you define the structure just once? You've got these placeholders in curly braces, concept and domain. Then your application can just plug in whatever values it needs, like rate limiting for the concept and APIs for the domain, and boom, you get a perfectly formatted, totally consistent prompt every single time.
And this is the whole point. Those variables, that is your superpower. It's what turns a simple, static piece of text into a powerful, dynamic, and reusable piece of your application's logic.
So, to bring that car analogy all the way home, if the model wrapper is the standardized engine mount, then the prompt template, that's your ECU, your engine control unit. It's the little computer that fine-tunes everything, controlling the fuel and the timing with precision, telling that powerful engine exactly what to do to get predictable, high-performance results.
All right, let's land this plane with our final section, the production mindset. It's time to bring these two big ideas, taming the model and treating prompts as code, together. Let's see how they combine to create a truly professional approach to building with AI.
So let's break it down one last time. Model wrappers, they let you manage the engine, making it standard and swappable. Prompt templates, they let you manage the instructions you give that engine, making them testable and reusable. And when you put them together, well, they're not just a couple of neat tricks. They are the absolute bedrock, the foundation for building any serious, reliable AI application.
You know, the biggest problem is usually getting all the pieces to talk to each other reliably. You've got your prompt, you call the model, you try to make sense of what comes back. Getting all that to work together consistently every single time, that's the real challenge.
Well, this is where LangChain comes in with something really cool called the LangChain Expression Language, or LCEL for short. And honestly, the best way to think about it is like a pipe operator, You just pipe one component into the next. It's that elegant.
But here's why this is such a game changer. It's not just about hooking things up. With LCL, you're building a proper modular system. You can stream outputs to make your UI feel snappy. You can build in retries and fallbacks for when things go wrong. And, this is huge, you can actually unit test each individual piece. This is how you build for production.
All right, enough talk. Let's actually see this thing in action. I'm going to walk you through some code, just like we're running it on our own machine right now.
Okay, so here's our setup. We're pulling in Chat OpenAI and Chat Prompt Template. We instantiate our model. We'll use GPT-4o Mini here, and then we create a simple prompt template. A system message and a spot for the human's question. All pretty standard so far. Okay, now look right here. This is the magic. See that line? Chain equals prompt by LLM? That vertical bar, that's it. That is the entire LangChain expression language in action. We are literally piping our prompt into the model. One single character is all it takes to create the chain. How cool is that?
So let's run it. We'll invoke the chain and ask, what is idempotency? And boom, we get our answer. Clean, direct, perfect. It works. But think about a real user. Are they going to be happy just waiting for this whole block of text to appear?
Probably not, right? In a real UI, nobody wants to stare at a loading icon. You need to show that something is happening. You need to stream the response back. That's what makes an app feel alive.
And you might think that's going to be a big, complicated change, but with LCL, it is unbelievably easy. All we do is change that one word. Instead of .invoke, we just call .stream. That's it. The whole chain we built stays exactly the same.
And when we run it now, look at that. The output starts flowing in, piece by piece.
This is exactly what you need for a good UI. You can now show the response to the user as it's being generated, word by word. It's that responsive, real-time feedback that we're all used to now. And there we go. The full answer is complete. That is a way better user experience, and all it took was changing a single method call. That's the power we're talking about. Okay, so this is great. We've got our chain, it's streaming, we're feeling pretty good, right? But we've just hit another one of those classic production problems. The model is just sending us back a big blob of text. For an application, that is a huge headache.
And this slide shows you exactly what I mean. On the left, you have what a demo bot might spit out. It's conversational, it's kind of messy. But on the right, that's what a production app needs. It needs clean, structured JSON. It needs to know, this is the title, these are the steps, these are the warnings. Without that structure, your app is just one sentence away from crashing.
The solution to this is called structured output, and it's exactly what it sounds like. It's a way to force the model to give you data back in a specific predefined format, like JSON, and then you check to make sure it did it right. Think of these as the guardrails for your app. They keep everything on track and prevent it from going off a cliff. So let's build those guardrails. Let's see how we can make our app truly production ready. And the whole process is this really elegant little loop with 3 steps. First, you define your schema, what you want the data to look like. Second, you instruct the model to follow that schema. And third, you validate the output and, if you need to, you can even make it retry.
So step 1, define the schema. We're essentially creating a contract. We're saying, hey, AI, I need a JSON object from you. It has to have a title key, and the value must be a string. It has to have a steps key with the list of strings, and a warnings key, also with the list of strings. There's absolutely no room for error here.
Okay, so now for the really powerful part. After the model responds, your code automatically checks its work against that schema. Does it match? Great, success. But what if it doesn't? Well, you can build a system that automatically goes back to the model and says, hey, you messed up. Here's the error. Try again. It's basically an automated self-healing system for data quality.
And this, right here, is the whole point. This is the difference between a cool toy and a real application. It's the combination of the 2 things we've talked about, the easy composition you get with LCEL and the rock-solid reliability you get from structured outputs. That's what takes you from a fragile demo to a robust app you can actually ship.
Okay, next up is memory. Now, in a demo, it might feel like the model just magically remembers things from the conversation. But in a production application, memory isn't magic at all. It's just good, solid engineering. You have to make a conscious choice about what information to store, where to put it, and exactly when to pull it back out to create a conversation that actually makes sense.
And this really breaks down into 3 main buckets. You've got short-term memory, which is just the recent chat history, like remembering you're both talking about invoice number 123. Then there's long-term memory, which stores facts that don't change, like that a particular customer always prefers to be contacted by email. And then there's retrieval memory, which is super powerful. It can actually search through past conversations to find similar problems that you've already solved before.
This brings us to what is maybe the most important pattern in all of modern LLM development, RAG, which stands for Retrieval Augmented Generation. This is the whole talk to your documents pipeline. It's how you get an LLM to answer questions based on your company's private knowledge base, like a clinic's cancellation policy, instead of just making stuff up. So how does this whole RAG pipeline actually work? Well, first, you load all your documents, your PDFs, your text files, whatever. Then you split them up into smaller, more manageable chunks. Next, you convert those chunks into numbers using something called embeddings, and you store them in a special vector database. And finally, when a user asks a question, You retrieve the most relevant chunks. And here's the kicker. You feed only those chunks to the LLM to generate a grounded, factual answer. But, and you really have to hear this, RAG is not a magic bullet. It can, and it absolutely will, fail in production. What happens if your chunking strategy splits a key sentence right in half? What if your retrieval system just doesn't find the right document, even though it's in there? Or what if the model just completely ignores the context you gave it and makes something up anyway? And what's your plan for when no relevant documents are found at all? These are the real-world engineering problems we have to solve.
Okay, so our app is grounded. It's not going to make stuff up. What's next? Well, now we give it skills. We're going to move beyond just answering questions to actually doing things in the real world. This is where we build in controllable, autonomous actions.
And we do this with something called tools. Now, it sounds fancy, but a tool is really just a simple function, some Python code, for instance, that has a very clear description of what it does. This lets the LLM understand what the tool is for and when it should call it. This is how you give your app superpowers, like being able to check a live calendar or book an appointment.
And the brain of this whole operation, that's the agent. The agent is the reasoning engine inside your application. It looks at what the user wants and then figures out which tools to use, in what order, and with what information. It's the orchestrator that turns a really complex request into a series of simple, manageable steps.
Let's walk through an example. Say a user asks, "Book me the earliest appointment you have next week after 3 p.m." The agent first sees those constraints, next week and after 3 p.m. So it calls a tool to get all the open slots for next week. Then, it filters those results to find only the times after 3 p.m. After that, it calls a second tool to actually create the booking. And finally, it confirms all the details back to the user. See? Step by step. Now, you could build a simple agent with just a while loop, but honestly, that's super fragile and a nightmare to debug. For production, you want to use something like LangGraph. It transforms your agent into a controllable state machine. This is a huge deal. It means you can build in complex cycles, you can add checkpoints for a human to review and approve things, and you can design the whole thing from the ground up for serious reliability and monitoring.
So at this point, we've built a really powerful app. It's got memory, it can talk to our private data, and it can take actions. But how do we actually know that it's safe and effective? This brings us to what might be the most critical step of all, shipping with confidence.
I absolutely love this metaphor because it is just so true. Shipping an LLM application without tracing and evaluations is literally like flying a plane with no instruments. You're just flying blind. You have no idea where you are, where you're going, or if you're about to fly straight into a mountain.
So if we're flying a plane, we need an instrument panel. And that's exactly where a tool like LangSmith comes in. It is the instrument panel for your LLM application. It gives you complete visibility, letting you trace every single step, every tool call, every single thought your agent has. And it lets you evaluate its performance against a set of standards to make sure it's high quality.
And when we say evaluation, we're not talking about some vague feeling. We're talking about a hard checklist of questions you have to be able to answer. Is the output factually correct? Is it actually grounded in the documents we gave it? Does it know how to safely refuse harmful requests? Did it call the right tool with the right data? Did it return valid JSON? You have to be able to answer yes to all of these before you go live.
All right, we are building something genuinely useful, a real AI assistant from scratch. We're going to be using some seriously powerful tools like Retrieval Augmented Generation. You'll hear that called RAG, and LangGraph. And don't worry, I'm going to walk you through every single step.
So, what if you could build an AI that doesn't just know about the whole internet, but knows your stuff, your specific documents, your data, and can even take actions for you? It sounds super complex, right? But honestly, with frameworks like LangGraph, it's way more straightforward than you'd think. So here's our goal. We're going to build a policy and booking assistant. And the best part, everything you're about to see is totally copy-pastable. So you can literally follow along. And by the end of this, you'll have a working AI agent. No kidding. We're going to tackle this in 4 simple parts. First, we'll figure out exactly what we're building. Then we'll get the project set up. After that, we'll configure the environment. And finally, the really cool part, creating the AI's memory. Okay, so what exactly are we building? This isn't just some generic chatbot. Nope. We are creating an agent with a very, very specific purpose. Our little assistant is going to do 3 key things. It'll answer questions based on specific documents like clinic policies. It'll also handle booking requests. But, and this is absolutely crucial,
It's going to have a safety rule built in to prevent hallucinations. You know, when AI just makes stuff up? Yeah, we're not having that. If the answer isn't in the docs, it's going to say so. That's the power of RAG.
All right, let's get our hands dirty with part 2, the project setup. Getting this foundation right from the very beginning is going to make everything else so much smoother.
And it's really just a simple two-step process. First, we'll create the folders our project needs to live in, and then we'll install all the necessary software libraries that are going to power our AI. Easy enough, right?
So here's the project structure you'll need. You've got folders for docs and storage, plus a few Python scripts. Now, for the moment, the most important one to pay attention to is that docs folder. That's where you're going to drop the text files that will become your AI's entire brain.
Now, what's really interesting is what's under the hood. LangGraph, that's the core framework, basically the architect for our agent. LangChain OpenAI is our connection to the big AI models. Then there's ChromaDB, which is going to act as our AI's smart library, its memory. And finally, Python.environment, which helps us handle our secret API keys safely. Okay, next up in part 3, we're configuring the environment. You can think of this step as giving your AI the special key it needs to unlock those powerful language models from services like OpenAI.
So the most important thing here is security. You'll see a file called .env.example. That's just a template. You're going to copy it, rename the copy to just .env, and that is where you'll paste your actual secret API key. Seriously, never, ever share your .env file with anyone. We're now at what I think is the most fascinating part of this whole project, creating the AI's memory. This is where we take our plain old text documents and transform them into a format the AI can search and understand in an instant. It's called the ingest process.
And here's the core concept right here. We need to ingest docs into a vector DB. That DB stands for database. This whole process is the heart of that technique I mentioned, Retrieval Augmented Generation, RAG. This is exactly how we give our AI a custom, reliable brain that knows our stuff.
So how does this actually work? Well, the script we're about to run does these 4 things. It grabs your text files, breaks them into smaller, more manageable chunks. Then it converts those chunks into these numerical representations of their meaning. They're called embeddings. And finally, it stores all of that in our special database.
So what on earth is a vector database? Well, it's not like a normal database that just does a keyword search like hitting Control-F. Now, this is way smarter. It stores information based on its semantic meaning. The best way to think about it is like a super smart library index that understands concepts and ideas, not just words. It's the secret sauce that lets the AI find the most relevant info instantly.
Okay, so with everything in place, we've got our folders, our libraries are installed, our API key is set. All that's left is to run one single command in your terminal. This one little line is going to kick off that whole ingest process we just talked about.
And boom, success. After you run the script, you should see an output that looks just like this. It's telling you it found your documents, it broke them into chunks, and it stored them safely in the vector database right inside your storage folder. That's it. The AI's memory is officially built.
I mean, just think about that for a second. With just one command, we've created the entire knowledge foundation for our custom AI. All the heavy lifting, the reading, the understanding, the indexing, it's all done.
So we've given our AI a purpose, a structure, and now a memory. The foundation is absolutely rock solid. So the big question is, what's next? Right? How do we actually connect this new memory to a conversational agent that can talk to us and use it? Well, that's the next step. But for now, the most critical part, the AI's brain, is complete.
Well, it all starts with the absolute fundamentals, chat models and prompting. From there, you learn to build real pipelines with LCEL. That's the LangChain expression language. Next, you tackle a huge challenge, getting reliable, structured outputs. Then you move on to RAG, which is how you ground your app in your own data. After that, you give it tools so it can interact with APIs. And finally, you pull it all together to orchestrate reliable agents.
Okay, so you've built your app. It works. But hold on. Before you even think about launching, it is time for that pre-flight check. This is that critical stage of tracing and evaluation that ensures you can actually ship with confidence.
And your main tool here is LangSmith. What is it? Think of it as your application's flight recorder and simulator, all rolled into one. It lets you trace every single step your app takes, which is absolutely invaluable for debugging. But maybe even more importantly, it lets you do offline evaluation,
so you can test changes and catch problems before they ever get to your users.
But that's the key question, right? It's easy to say test your app, but that's way too vague. What are the concrete, measurable things you should actually be looking for?
This is what flying with instruments looks like. You're tracking very specific metrics. You can check for correctness against a set of right answers. You can verify groundedness. Did the app actually use the documents we gave it? You can test its safety, check its tool accuracy, and even make sure its output format is perfect. This is how you know it's working properly.
With our pre-flight check complete, we are officially cleared for launch. So, Section 3, Deployment. Your app is built, it's been tested, now it's finally time to get it out there for people to actually use.
And you know, on the surface, the idea of deployment is pretty simple. You take that powerful chain or graph that you've built, and you just wrap it up behind an API. This gives you an endpoint that other services or a front end can call to get a response. Sounds easy enough.
But here's where we got to pause for a second. Okay, you have an API endpoint. Is that really enough for production? Is that simple wrapper truly ready to handle thousands of users and all the chaos of the real world?
The answer is a pretty clear no, which brings us to our final and maybe most critical section for any real-world app, operations, or as we're calling it, mission control. This is everything that has to happen after the launch.
See, a real production-ready app needs what's called an operational envelope. It's like a protective layer that sits around your core API. This includes stuff like authentication to control who can use it, rate limits to prevent abuse, caching to speed things up and cut costs, robust logging and tracing, and of course, cost controls, so you don't get a giant surprise bill.
And this right here, this is the secret sauce. This operational envelope is what transforms a clever project into a professional, durable product. For any serious application, this stuff isn't optional. It is absolutely essential.
And that brings us right back to the full picture, the complete 8-step map for the entire lifecycle. You start with the 6 core development steps. You add the essential guardrail of tracing and evals, and you finish with that operational layer that makes it truly ready for production. From an idea all the way to execution to mission control.
So there you have it. That's the blueprint. It's a clear, step-by-step path through what can often feel like a really complex and chaotic landscape. It gives you the structure you need to build with real confidence. The map is in your hands now. The only question is, are you ready to start building?